Okay, so we are doing some review for the moles test. Number one, what is the total number of atoms contained in a 1 mole sample of helium? So let's first review. 1 mole is equal to the gram formula mass, which is when you add up all the masses. It's equal to Avogadro's number, which is 6.02 times 10 to the 23rd particles. And it's also equal to 22.4 liters of a gas at, it says AF, at STP. So how many atoms are in 1 mole of that? Well, 6.02 times 10 to the 23rd atoms. It's Avogadro's number, choice D. What is the total number of atoms in 0.25 moles of nitrogen dioxide? Okay, so now we're going from moles to particles, which means we're going to multiply 0.25 times 6.02 times 10 to the 23rd. So what I do is we multiply coefficients only. So 0.25 times 6.02, and we get 1.505. Then we tack on times 10 to the 23rd. Then I have to look and see which one of these 4 choices is closest to that. It's choice A. All right, the table below shows the volume and temperature of 4 different gas samples at 100 kilopascal, almost standard pressure, which would have the equal number of atoms. So this is called Avogadro's hypothesis, which states that if you have the same pressure, which we do, and if we have the same volume and the same temperature, you'll have the same number of particles. So they're all at the same pressure. Helium and argon are at the same volume, and they also have the same temperature. So helium and argon would be our answer. Helium and neon do not have the same volume, so that's why that's not it. Neon and argon do not have the same volume. Neon and krypton have the same volume, but different temperatures. So we need to have temperature, pressure, and volume all the same. At STP, a liter of helium contains the same number of atoms as 1 liter of something else. Doesn't matter that it's not the same thing. So it's the same volume. I didn't put B here. All right, number 5, the formula mass. We call it gram formula mass. The GFM is the sum of the atomic masses, sum of the atomic numbers, product of atomic masses, or product of atomic numbers. So the sum of the masses, we add them up. Now, you'll see on the right, I have some colorful numbers already in green and pink. That's because I, to save time, have already gone to periodic table and I've looked up the masses, so I didn't want to waste our time in this video. So when it says, what is the gram formula mass of calcium hydroxide? You'll see there's a 40 under calcium. Hard to read, but it says oxygen, 16 times 2. Why is it times 2? Because there's that 2 outside. And it's going to be hydrogen's mass, which is 1 times 2. And we're going to add them all together. So 16 times 2 is 32. Plus the 40 from the calcium, plus the 2 from the hydrogen is 74. And then our units are grams per mole. What is the formula mass of this thing? So I've already written in the mass of iron is 56. Nitrogen is 14. However, there are 3 of them. Oxygen is 16, and there's going to be 9 of them. So 14 times 3 is 42. And then 16 times 9 is 144, and then a 56. So let me add those up, and I get 242 grams per mole. What is the mass of 1.5 moles of this? So now we need to use GFM in order to get to the final answer here. So 1.5 moles, 2 grams, we're going to multiply by our GFM. So first we need to find GFM. The mass of carbon is 12. Oxygen is 16 times 2. So 16 times 2 is 32 plus 12. So the GFM is 44. That's not our answer. We're not done. So we're going to take 44 and we're going to multiply it by 1.5. That's our answer, which is 66. So be careful. If you chose 44, you're on the right track, but that's not the final answer. That's just going to guide you to the answer. A 1 mole sample of krypton gas has a mass of, this is asking you, what is the GFM of krypton? I've already looked it up. It's 84. What is the GFM of this large thing, which is copper, Roman numeral 2 sulfate, pentahydrate? So these numbers are very small and hard to read, but copper is 64, sulfur is 32, oxygen is 16, but there are 4 of them. So 64 plus 32 plus 16 times 4, which is also 64. So I made a mistake. Is 160 from this side. And then water is 18. I just know that. So 5 times 18 is 90. Add them together and you get 250. All right, how many moles? What is the number of moles in a 220 gram sample of CO2? And it told me the GFM. Thank you. So grams back to moles, we're going to divide 220 divided by 44. 220 divided by 44 is 5. The total number of moles represented by 20 grams of that is, so 20 grams to moles. So grams to moles, we're going to divide by GFM. So first, let's find GFM. Calcium is 40. Carbon is 12. And then 16 times 3, which is 16 is oxygen. There are 3 of them. So 100 is the GFM. So 20 divided by 100 would be 0.2. I should have known that. Which term represents the simplest whole number ratio of atoms? The simplest whole number ratio of atoms is called the empirical formula. So number 14 says, which is an empirical formula. If you can simplify the subscripts, it is not empirical. So see how we have a 2 and a 4? I can make this a 1 to 2, which means that's not our answer. Part B is our answer because I cannot bring that down. Let me continue though. Take a 3 and a 6 down to a 1 to 2 again. And I can take a 2 out of each. So yeah, B was already simplified. So which one is most simplified? I can simplify that, and that. So it's choice A. If you ever see something with a 1, that's probably your answer. Which 2 terms represents types of chemical formulas? Empirical and molecular. What is the molecular formula for that whole thing? Okay, so molecular formulas, let's define it, is the actual number of atoms, or another way to think of it is you have some multiple larger. So first of all, see how this is all stretched out? All the C's are not grouped together, the O's are not grouped together, the H's. This is called a structural formula. We'll talk about that in organic chemistry. So right now, let's put all the C's together. 1, 2, 3, 4. Now let's put the H's together. We have 3, and 2 more is 5, and 3 more is 8. And then the last one we'll do is oxygens. There are 2. C4H8O2. And that is our answer. Which molecular formula is also an empirical formula? So which is already simplified? That would be not this, and not this, and not this. D. All right, 19. What is the percent composition? So first of all, this is on table T. Part over whole times 100. So what is the percent composition of that? Okay, so calcium is 40. The whole thing is 200 times 100. I looked that up. So bromine is 80, but there are 2 of them. So 160 over 200 times 100. So let's figure out what those are. So 40 divided by 200 times 100 is 20% calcium, which already gives me my answer. But just for kicks, 160 divided by 200 times 100 is 80. So it is choice A. Which is the greatest percent composition by mass of sulfur? So sulfur is 32. 137 plus 32. So the first one is 32 over 137 times 100. The second one is 40 plus 32. So this is 32 over 72, 100. This is 24 plus 32. 56. And 88 plus 32 is 120. So it says the greatest percentage would have the closest ratio. So, I mean, I could do the math. 32 divided by 137 times 100. This is going to be 23.3%. 32, holy cow, divided by 72 is 44.4 repeating, so 44. 32 divided by 56 is going to be 57%, that's a 5. And 32 divided by 120 is going to be 26.6, so 27. So this is the third one is the answer. This one, see? And I didn't really even need to solve it because I see that these numbers, numerator compared to denominator, are very close together. Percent by mass of water. A 4.4 gram sample was heated until the water was driven off, and then we have anhydrous is 4.3. So 4.4 has water, 3.3 does not, 1.1 is the water. So what percent? Part is the water, whole had the water, times 100. So 1.1 divided by 4.4 times 100 is 25%. A hydrate is a compound with water molecules incorporated into a crystal structure. In an experiment to find the percent by mass of water in a hydrated compound, here we go. So the crucible and the hydrated crystals before heating, you've got your crucible, and then after heating. So 7.5 minus 6.9. So the hydrate is 0.6. 7.20 minus 6.9. So the anhydrate is 0.3. So the water is 0.3. So 0.3 over 0.6 times 100. This is getting messy, sorry. That looks like 50% to me. So that is choice B. All right. The percent by mass of oxygen in that is closest to. So it told us the total, which is 40. So that's our mass of whole. 16 is our oxygen times 100. 16 divided by 40 times 100, 40%. Okay, so we got some scientific notation that's snuck in here. So we have a negative exponent. That's because we have a small number. So 1, 2, 3, 4, 5, 6, 7. 10 to the minus 7. Choice B. Now you need, okay, so we need to, first we need to put this out. So 10 to the third, you mean move 3 spots, 1, 2, 3, but that's kilometers. And then of course you're going to multiply that by 1,000 to get meters. Man, that's mean. So mean. That would be 3 million. Yeah, choice D. Show a numerical setup for calculating the percent composition of oxygen. Okay, so oxygen is a mass of 16. However, there's 3 of them. So what is that, 48? Yeah. So that's the mass of the part. The whole, it told us, 102. It's a percentage times 100. Don't solve it. You're done. Okay? Okay, given the compound, calculate the molar mass of the compound. So that's GFM. So this is 16. Well, sorry. Let's go in order. 12 is the mass of carbon times 4. 1 is the mass of hydrogen times 10. 16 is the mass of oxygen times 8. So 16 times 8 is 128. 12 times 4 is 48. 1 times 10 is 10. And we're going to add those up. So 48 plus 10 plus 128 gives you a mass of 186 units grams per mole. Then it says calculate the number of moles in 17.7 grams. So grams to moles, we divide by GFM. 17.7 grams divided by 186. Didn't say anything about sig figs, so I'm going to go with 0.095, and this is going to be moles. What is the empirical formula? So we go back up here and we make it most simplified. Looks like I can take a 2 out of everything. C2H5O4. That can't go any further. You got to read that. Of course, what is the GFM of that? So, okay, 40, and I just know these off the top of my head. You obviously should probably look them up. So 40 plus 32 plus 16 times 4, which is 64? 136. And then water is 18. There are 2 of them, so that's 36. So 172, and the units are grams per mole. Show a correct numerical setup and the answer for percent composition by water. So this is part over whole times 100. So the mass of the part would be the 36, the 2 times H2O. The whole thing is 172. We've already done that. Times 100. You absolutely have to show the times 100 in order to get full credit. We can't assume that. So your final answer is going to be 20.93. We can accept 20.9, we can accept 21, and of course units are percent. Didn't say turn on to sig figs. Tetrachloroethane is a solvent, right? It's empirical formula. So let's take a 2 out of both of those to make it C1Cl2. All right, if you have any questions, please reach out. Thank you.